Hi everyone, welcome to another episode of the Lisp Study Group. I'm your host Ron Baden with Atlanta Functional Programming. And today, which is our third part of our exploration of Unix command line option parsing libraries inside Common Lisp, we'll be discussing actually a library that we've covered on this stream, but we didn't cover the command line parsing piece, and that is the UIOP library. As many of you know, UIOP is available for you at your disposal as part of the ASDIF distribution. It comes, but if you need to, you can also, if you have quicklist installed, provide. It has a dependency. It is available on quicklist through a simple quick load. If you just do a system apropos on it, you can see that it is available inside the quicklist distribution server that's available on AWS. As I mentioned before, UIOP is a fairly large library. I encourage those of you who have not seen AFP's that is Atlanta Functional Programming series on UIOP to look at our playlists on our YouTube channel for more information about details on UIOP in general. One of the sub-libraries that we're going to be covering, which pertains to today, is actually the image library, the image package as part of the UIOP library. This package deals with a lot of things related to creating essentially dumped images. You can provide hooks into there, as you recall, to restore and deal with providing like pre-commit functions that get started when the image starts up and so forth. One of the things that it provides is specifically something that deals particularly with command line arguments, and it comes in two flavors. There's a global variable that's available in the UIOP called command line arguments. If I can actually get, let me see if I should have loaded it already, but we'll see. Okay, seems to be there. Let's see. This does not throw an error. Yeah, as you can see, this is, unfortunately, my autocomplete is giving me a little trouble this morning. Let me just try doing this here. Interesting. Okay. This took a minute. Let me see if this works here. Okay. So this global variable keeps track of what's ultimately being passed inside that's being passed in through standard in from the command line into the image itself. Those of you who are running Windows, for example, UIOP's image library, as far as I know, with SPCO, would work in much of the same fashion, but I encourage you to experiment and try that out yourself. This is a little bit more portable than some of the other ones that we've encountered, in that it works not only for Unix, it can also work for command line parsing inside Windows, as far as I know, from what I read. This command line arguments global variable is actually ultimately used inside this function. Let me just close this guy out for a minute. This is our server running for today's coding session. If we actually look at the command line arguments function, this function extracts user arguments from the command line invocation return process. So right now, one of the things that this kind of as far as I can tell, can do is it will actually run an additional function that would grab all the command line arguments that are being passed in from the process invocation, and then it will go ahead and parse them into these argument objects, which I think if I do image, let me just describe UIOP image arguments. Looks like arguments is a class. It's a symbol. Okay, all right. So that means these are. That's right. I forgot about that. These arguments are basically just nothing more than it's an accessor to a larger. It's basically the optional argument that's being initialized to a default value here. If you recall, this one here, this in this lambda list, this second argument here is the symbol in which that it's going to be bound into, and this is going to be what we're passing in. This is a separate function as well, the UIOP raw command line arguments. That will give you what is literally passed into a function. This will just give you what the command line was as is, right? So let's try this out for a minute. Let me go ahead. This is for later. This is part of our discussions for later. Let's go ahead and clean this up a little bit here for our discussion, and comment out this guy because we don't need this right now. We're going to be updating this program that we had last time for building up an Echo client to use essentially our UIOP library instead, in which case we can actually compare and contrast a couple of things. Let's do that. Yeah, I forgot that there's a shortcut key for that. Okay. Let's go ahead, RV. And what we'll do is we're just going to go ahead and print out to the command line our image raw command line arguments, right? Now, if you notice, right, my apologies, I gotta remember to always put that in there for the time being. Okay. One thing to notice about this function, if you actually, oh, my apologies. Is if you run this in the command line, in the REPL, okay, you will not get what's actually being passed in. It's the invocation of the entire process that you're currently running, all right? So what that does is it in this case, since we're running SPCL, okay, in the REPL, we didn't pass in any additional arguments to the REPL. What you're ultimately getting here is going to be nothing more than just SPCL, okay? This makes interacting with the raw command line arguments when you're doing interactive development a little bit, what's the word I'm looking for? A little bit more tedious, because what you're going to have to do is you're going to play around with this a little bit. You're going to probably have to run a shell. So we're going to go ahead and run eShell for the time being. Hopefully there isn't any screwy interactions that we're going to be having to deal with. Let me just go ahead and open up a new shell. Okay. So we're in our little location here. So when we tried to build, let's build, remember, if you're running ROS, you can actually just go ahead and build it as such. It's going to take a second here just because I'm running a couple of processes at the same time. That's a little bit memory heavy, so the compilation process is going to take just a minute. Now, once this is done and we try to run echo client UIOP, you can see that you're actually getting the full command line like a list of arguments. Okay, so if we pass in, for example, here -h localhost -p5000, just like what we're going to do with our clients, you're going to get each of the individual arguments, much like UNIX option does, has a list of arguments. And you could certainly use this piece to actually go in and grab that information. The other thing that you could do, though, is I'm pretty sure I could do this too if I can replace this guy. This one should do essentially the same thing, but we will see what happens when we run this. Okay, so let's run let's build here again, and you'll see the same kind of idea to actually grab this information. And we could even try this here on you'll see that there's nothing passed in here. In the case of when we run this on the command line, what happens is the first time you run it, obviously you didn't pass anything into the command line arguments, because what it's doing is unlike raw command line arguments, which is literally taking the string that's being passed in, alright, process invocation, and then parsing that by doing essentially a string split across the string, and then making each thing that that's passed in a part of the result set. And that includes, if you recall, you're using other languages like C, for example, the first argument is oftentimes the name of the executable, right? So you're going to end up having to make sure that you start with the second argument thereon. And it's much in the same way here with command line arguments. It eats that first argument and then tells you that, oh, you didn't pass in anything to this executable. So it's a little bit more cleaner and more representative of what's actually being passed in. Now, when you do pass in arguments, this is like before. This is actually giving you the list of arguments. Again, it's giving you the I'm pretty sure you can actually use this like an associative list. It will give you the argument has a key, and then the value of what's being passed in has a second option. One thing to note about this is what this somewhat buys you is the fact that you can now use essentially the same idea and the same approach that we would do with the Unix options library to actually go in and construct this. But there is a slight difference in what you can actually do and what you can't do. All right. The one thing that I've noticed about this library, at least this package, when I initially like played around with a couple of things here, is the fact that Unix options, because it's essentially a thin wrapper around get ops, you get the long name version of your command line options to be hooked up to your shorthand or short named symbols for the command line options in the same function call. Okay, here at least I haven't figured this one out because it doesn't look like there is any clear way from looking at the code and looking at the documentation to actually group those two things together in such a way that you end up not having to write additional code to handle each individual case separately. All right. If there is a way for folks who are more familiar with using UIOP image than I am, please let me know. Put it in the YouTube comments, and I will go ahead and do like a follow-up video with some of that feedback, just to let other folks know. But this kind of separation gives you a lot more flexibility in the case of what you can and cannot support in terms of your command line options when you're parsing them. At the same time, for folks like me, at least, who wants a single tool to actually leverage some of this, that portability and that flexibility strives in the way of actually having to deal with maintainability, because you have to actually make sure that you're dealing with both cases, the long option version and the short option version. And some folks prefer one versus the other. Sometimes it's easier to have both. I mean, a lot of tools provide you both. But the utility itself does not actually give you that ability. So one way to essentially leverage this, and we could show this to you, is instead of doing this, let's go ahead and make this into a let statement and wrap this guy and say this is our args. Okay. By the way, for folks who might be wondering why I'm not passing in just argv into this, I could do the same thing. So let me just do that one final example. But my understanding is this should give you similar results. Okay. So now if we do this, if we use argv directly instead of the raw command line arguments, which again hooks into the runtime and actually grabs it from the process invocation, we can now play around with this here in much the same way. So if we do localhost, then we get the same here. But notice the difference between this and what I showed you before. The first argument is actually eaten up. All right, and that's because of the way that function is designed. It actually, if you actually look at the code, it literally just takes the arguments and gives you the rest of them. So because raw command line arguments passes in has the first argument, remember, the name of the executable, and the way that that function is written, it actually always what's the word? It always eats the first value and gives you the rest of the arguments. All right. Now the cost of that is obviously as you can see here, the loss of one of our command line options if we're trying to run this in the REPL, or if you actually run this in the actual shell, you're going to get the same sort of problem. All right. So, and again, this is because of the fact that it's not actually returning in that function called the rest of them. But, let's try this out just to see some of the differences. Okay. And it gives you the same results. And again, this is natural because argv when you're passing in, it doesn't actually in the Lisp code, this rest argument here is after your executable name. All right, when that's the only time it's going to get collected. It will not get collected any other time. So in this case, the first argument in argv is going to be -h, not the name of the executable, like you would in straight up raw command line arguments, or if you're using other languages, the same sort of idea. Think of argv in C or C++, because it's the same idea there. So the result of that is obviously, I'm just going to quickly brief this in because this will essentially look fairly similar to what we were doing before, but as I mentioned, this looks very much like a associative list. So let's see if we can actually grab our arguments. Okay. And at this point, we are not using argv's infrastructure, we're using UIOP's infrastructure. So now we have our arguments. We're going to go and grab, let's see, let's go ahead and print. Since we're passing in -h, let's see what item -h. Let's do the A list, which is going to be our args, and we got to actually change the test function, because the test function, it is no longer actually going to be, in this case, EQ. It's going to be actually string equals. So this will just give us the hosting option, and then actually let me go ahead and make this because I'd like my new line here. Okay. So now, when we run this, sorry, I have to go here. Hoping that this should do what I expect it to do, but I'm pretty sure that this is going to do incorrectly. This is actually, on second thought, this may not work because of the fact that I'm pretty sure A lists have to have essentially a list of const pairs. So let's see, like that means dotted pairs. But we'll see if this works. Yeah, that's what I thought. It wasn't going to work because of the fact that this is not a list of dotted pairs. So the way we would have to go grab the list of command line arguments is slightly more different. So what we're going to have to do is we're going to have to go through and loop through each item. Might be easier to do this with indexing. Yeah, this might be easier to use indexing for into the list because of the fact that we want the next item in the we want the next item in the list. We don't want the current one. So one way of doing this, I'm not going to write a real do. I'm just going to use do times idx and make this into the length of the arguments. Okay. To access the index of it, and then what we will do is this is going to waste some time, but this is one way of actually grabbing the information. You can also use what's it? Find the index where a particular item is in a list, but I don't think find will give you the actual. Let me see something here. Let me see. Post. Oh, sorry. And the those are put in string equals. So it finds it, but it doesn't actually tell us what the index is on this. So this is probably much easier. So we just go and do a simple string equals, iterate through the list, grab the index that we want by doing this ELT args x, and we actually write when now we know that the next item is always going to be the argument, the value of the argument. Yeah, we could just do that. Print. There's another way of doing this that came in my head that that I'll show after I show this particular example, and then that's it. So now let me go ahead and I think there's a way. Oh, sorry, I forgot to build it. Now here, if we run this, you'll see that it's going to take a minute, but it's going to go ahead and get our local host. Another way of actually grabbing this stuff is actually converting this into an A-list, because I think that's probably a better way of doing it anyway. But the way to do that is, how would we have to go and create an A-list out of... I'm trying to remember now. What's the way to create an A-list out of a list? This is... think it's just a map function. You just need to, yeah. So one way of doing this is literally let's see here, not ELT. That will give me what's that function? Describe find if. I know it's a compiled function, but what is the return value again of this guy? From N, T does not give me the index in which it completely grabs it from. Okay, I think I have a way of doing this. So we first go ahead and do this way, which is okay. And I'm not going to call this guy args, this is raw args. Okay, this is what's actually passed in as our list. Okay, our args is going to be essentially loop for I from 0 to length of args by 2. Okay, so we're essentially going to skip every two. And if you recall our loop syntax, by doing this, you're essentially going to get, oh, sorry. If we collect it, you'll end up getting the odd numbers. So we're just skipping it by 2. What we're going to do is collect cons of ELT args I and ELT args inc fi. And what this is doing is creating our list of dotted pairs for us, right? And now what we could do is just do what I was saying before, which is format T, have that json. Args test string equal. Thank you. I caught that too as well. There was a comment about the fact I was using the wrong length arguments. This should work, but let's go ahead and test the idea out first. pretty sure set def parameter. List example. Oops. Remember cons dash h post cons dash p. Okay. So our list example is this. Oops. I gotta make sure that I not use that. It's a code. That's what I wanted. Shift G. Okay. So now we should be able to, we do this assoc dash h, which is the item that we're looking for, and we do test string equal. Okay, so this is going to give us exactly what we want. We want to get that item. All right, and that will give us essentially the dotted pair of all the things. All right. So now if we go ahead and run this, and now I know for folks who are looking at this, there are other ways of doing it. You could create a map, you could create a dictionary, and so forth. But there's some problems there too as well that you're going to have to encounter mainly. If somebody passed in, the same, and you're clearly seeing here a couple of things. You're going to have to do a lot of stuff that some of the other Unix parsing libraries that we've covered in past episodes from scratch because of the low level capabilities that UIOP/image is providing. It's not actually giving you a robust, a full featured. Although this low level functionality is robust, it's not full featured. It doesn't give you some of the other clean options of actually dealing with command line option parsing. But this does. Did I pass in the wrong thing? Hold on, let me see what I got here. I may have messed up here. Index 4 is too large for a list of 4. Okay, got it. This is because of the fact that I need to go -1 here. Because we don't want it to actually jump. It's going to start with 0, it's going to start with 2, then it's going to go to 4. And there are 4 arguments. So yeah, we want it. We don't. I forgot that this is not inclusive, right? This is inclusive. So actually, is loop inclusive? Let me just make sure one thing here. I keep forgetting this. 1, 2, 10. Does it include 10 at the end? Yeah, it does. Okay, so I have to go 1 less. Def. Okay. Oh, sorry, not def. Sorry. 1 minus is what I want. Okay. The reason we have to do 1 minuses is because of the fact that loop itself is inclusive. So since 4 is equal to 4, it's going to be included into that final image. It's not a half open interval. What is it complaining now? 4 is in. 0. Let me just check something out here. Since we have, it's all related to our our loop construct here that's happening. Let's do 1 minus 4 because this is, we're pretending that we're evaluating the thing. So by 2 collect 0 and 2. So where is it getting 4 from? Sorry, I forgot to compile this again. Okay, so now this is built. Okay, now this is what we're expecting it to do. And again, this is the reason for this this change is because, again, this is loop. The loop construct is does an inclusive interval. What that means is it will start from lower bound and includes the upper bound, and it only stops iteration when it goes 1 plus the upper bound that you provided. So in the case of like 0 to 10, as you saw, we actually go through 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we stop. Okay. What we want is actually it to not include that upper bound because, again, that's going to give you invalid array access. So we have to go 1 less than that to create that half-open interval necessary in order for the iteration construct to actually go ahead and complete itself. But once we do that, we end up getting our command line argument, all right? And now you could treat this as a normal associative array, which means you have a quick lookup with a test function here, as you can see here. Remember, the reason why I'm passing in the test function, this for folks who are just joining us, who have not been with us for a while, just a reminder on associative lists. Associative lists, as you remember, are a list of dotted pairs, okay? And the default key that's normally used with associative lists are usually a symbol. Main reason is because an EQ comparison is a lot faster than doing things like a string comparison. But since the command line arguments are actually being passed in as a list of strings, and I'm not doing any sort of additional manipulation to actually go ahead and make them into like their own symbols and so forth, you're going to have to change the default test function, which is EQ, to something else. Luckily, since the Common Lisp library provides us a generic equality function for comparing strings, we could just go ahead and change our test function from being EQ to being string equal, and that covers it. Now, for most cases, especially for command line parsing, this is pretty cheap. It is computationally expensive with respect to if you're thinking about it in terms of algorithms compared to an EQ comparison. But because we're not doing this at all so often, in fact, we're just doing this whenever we need to access a particular command line argument, I think it's not a big deal. But as you can see through this exercise already, if we actually compare, let me go ahead and open up, let me close this guy here. Sorry, not split. Yeah. Lower this. I want to do a side-by-side here. Let me open up this. Echo client Unix options. Alright. So, comparing this to our Unix ops example that we covered last week, this immediately should become apparent as to what this is, what this code is providing or isn't providing. Okay. Number one, remember we had a separate data structure completely dedicated to actually keeping track of our options. Okay, number one. Number two, we have, for each option the ability to provide both a short notation and a long notation. Here in the case of UIOP/image, because again it's a low-level utility, it doesn't actually give you that that feature for free. You're going to have to essentially write it yourself. Okay. And again, folks who are more experienced in it, I just could not find any way to actually go ahead and provide the host sign-ons, and this might be just me misunderstanding something inside of the function itself, and to determine how to actually use it. But I'm fairly certain that based on what I read and based on looking at the source code, I'm fairly confident that this is the correct understanding. It's a low-level library for command line options parsing. You have to create quick command line options. It doesn't give you the full flexibility of even some of the lower-level options parsing libraries, such as the wrapper library around getOpt, UNIX options, or in the case of our opt parse equivalent here, unixops, it doesn't give you a separate data structure for being able to keep track of it and providing information with regards to how these command line options are working to the user. You're going to have to essentially create the usage summary function. You're going to have to create the grouping and writing the logic in terms of your shorthand arguments and your long arguments. You're going to have to write in the case of unixops too. UNIXops gives us this nice ability of having grouped together the validation function that you would want to check your command line arguments against. And I think that's really, really useful for folks, especially when they are dealing with command line arguments of different types. This is, again, has to be written from scratch. Not a big deal. More code, though, more maintainability issues that you may have to think about. But it is a small thing to consider. But at the same time, UIOP is not a third-party dependency. It is available for you without you having to actually add an additional third party. Now, the only reason I added it at the top of this script is because you might have some folks who are running Linux Lisp distributions that are that have quicklist installed but are slimmed down in terms of what is installed and loaded into the image at the time that the image starts up. I don't know. So to be on the safe side, it is easier to just go ahead and just add it inside your quicklist list, just to make sure that it's in there. Most often, it's going to be already available, and just attempting to load that library is going to become a no-op. It's just going to return saying that it's loaded if you're actually looking at the build arguments of your image. And because of this availability, if you're in a pinch and you don't want to learn other options libraries and you want to just quickly get something up and running from a prototype point of view, UIOP is definitely available at your disposal. It is there. It can be used in terms of its basic functionality, and it does a fairly decent job in terms of actually giving you exactly what you would normally get if you were running and writing in a lower level language like, say, C. So a lot of that parsing that you would normally write in those languages, you would end up writing the same kind of logic here using this lower level utility. Are there questions? Give me just 1 second. Let me go and look at the stream. Looks like we're good to go here. Okay. There's another library that I want to cover because it was actually mentioned to me. I didn't think I would have time today, but since we have time now, we can actually go through it in terms of a live coding session. And that is something that was brought to my attention last week by one of our attendees, and that is the adopt library. Adopt is another opt parse, so that's Python's opt parse inspired library for parsing Unix style command line arguments inside Common Lisp. The author, Steve Losh, wrote this back in, it looks like a couple of years ago, actually. It is not, it's at least 2 years, maybe 3 years old. And it's from the API usage and the package, it looks like it is still actively maintained too as well. The main use case, I have not yet actually dug too deep into this library, so we're going to be working on it together. But this is a library that is available, as far as I can tell. Let me just go ahead and double check. It claims it's available on quicklist. Yep, it's available on quicklist, and you can load it. Let me go ahead and restart my list because I don't want to like mix the different libraries together just to prevent name conflicts. And we'll start another thing here. For folks wondering why we haven't actually completed this example for the Echo client, it's going to take a lot more work to actually go in and reconstruct exactly what we have in our other examples. So I'd rather not go through that low-level exercise just because it's going to be a lot of code with very little benefit in terms of illustrating what the library actually does. So I'm just going to keep that code in mind. And just to let other folks know, I will post, I know I haven't posted this yet, but I will post this set of Roswell scripts available for your benefit on Atlanta FP's GitHub repository, and I will post a link in the YouTube description after we're done. So let's go ahead and create a new you know what, I'm just going to first set this up using the shell runs init echo client dot this. Alright, so now let's open up echo client dot. Okay, and let's go ahead and grab our, so we want adopt. We haven't had a case to use Alexander just yet. We might not get through all of this demo today, but I'm going to see how quickly we can get through some of the basics of the library, just to give you guys a heads up on how to do stuff, and then we can finish off the demo next week if we need to, if there are questions too as well. UNIX on that. Okay, so I don't think I need anything else for right now. And then if I need, oops, there we go. And let me do this. And that. Okay, it's loaded. This is now, go ahead. So we now are in our adopt library. Okay. So to begin with, adopt actually starts out with the idea of starts slightly different than what other opt parse inspired libraries like unixops, as you see here, does in terms of actually developing the program. The first thing it will do is it kind of expects you to create kind of like an interface object. So we're going to do the same idea here. So this interface object is kind of a global variable, at least following what the example is in here. I don't know how often this is necessary, but we can see what it does. Now, what this interface will look like is basically the summary of what your program does when you execute it. Okay, this includes things like the name of the program, what exactly is its purpose, which is a summary function, and then it will provide you to give you the usage of what it's doing. A lot of things that we saw in the usage summary in the unixops library. All right, I'm just going to show briefly what this make interface function looks like here on the REPL. And you can see it has a bunch of options in terms of what you need to do. It returns essentially a command line interface object that you then ultimately use to go and manipulate and parse stuff from. All right, so we're going to go ahead and use this information here to construct our object. Okay, so there's a couple things here that we need to first pass in. Okay, the name of our program, which here in our case is going to be echo client adopt. What is its summary? Again, it's just going to be a simple echo client. Right. Now, the usage is obviously going to be including what options it provides. Now, we're going to go ahead and grab some of this off of our usage formatter that we created here for unixops for our purposes. First, do this little here. Where is it? It is. Oh, right, I forgot. This is automatically created for us in unixops. So let me do this. Let's grab it from our compiled version here. Echo client Unix. Oops. And this should throw the. That's right. I haven't built this one yet. Go ahead and build that. Oops. That. I could quickly whip up something too as well, but you know, it might be just easier just to do this too, to make it look more consistent to what we would be using. -h or -hope. Okay, let's see here. There we go. Let's see here, and then -h or -first name. This guy is required as well, but we're going to make, like before, we had our port defaulting itself to a particular port, right? So if you provide anything else other than this other guy, it will complain. Yeah. Let's go ahead and close this guy off, and we have again searching the contents. this is a little help individual that we will end up being printed out, just like what we see here. It gives kind of like a quick summary of the help of what this does. Starts a simple Echo client connecting to host provided host name and port, defaulting to port. Okay. We compile this, and now we have an object that is essentially here. If we do a star UI, you can see that this is actually an interface object that we could then obviously introspect and see what it created. One of the things that you could see is it doesn't have currently any options, or any short or long options, but they're treating each options things has a separate dictionary for quick usage, so you can actually do a quick lookup rather than jumbling them all into a single one, because now you can determine whether or not a short option or a long option is provided. Additionally, if you want to provide a man page, you could certainly do. So this is an optional thing that you can provide to help set up man pages as well. And this example thing is particularly useful too for folks who are making command line options that are particularly advanced, and you, depending upon the combination of command line options, you might want to provide, just like in a man page, what ways one might end up using this particular tool. So a lot of stuff that you would normally have to do from scratch, Adopt gives you for free, which is kind of nice. But the four things that we just showed you earlier, name, summary, usage, and help, are the four required ones that you have to kind of provide in terms of constructing this user interface, all right? And then we can start talking about the other stuff. Okay. There's this notion of grouping options based on particular time things, but I'm not entirely sure when one might want to end up using that as well. For folks who are wondering about fairly long help descriptions, has it points out here, you could certainly provide to the help contents itself. You could certainly use multi-line summaries by using format nil, and then use that to construct the help text. And we'll go through a quick example for that too as well. But what this object does is what is kind of nice is that you can now play around with kind of the user interface of the help of the UI as you're constructing the object. So if you call in help, it'll actually show you what way helps can be used. Although it looks like usage, there has to be a better way to actually, and this is kind of one thing that I was still trying to wrap my head around, is a way to replace the name that is provided by the UI, to kind of hide the fact that this is not technically SBCL. This is going to be the name of our executable. Okay, but again, I'm still kind of working my way through this this documentation as I'm kind of developing this example with you guys today. So let's quickly go through multi-line helps, just to quickly show you some stuff. So let's say that this is way too long for some folks, because me personally, 80 characters to align is much more. I'm much more happier to do this, and especially if you're doing demonstrations such as live coding at the presentation level, having the text run across the screen is kind of uh, somewhat inconvenient. So you can actually go ahead and create a def parameter that kind of extracts this help text. And all this is doing is it's going to use essentially a nice little feature. If you recall, you can use this to create multi-line text inside your thing, and then obviously when you print this guy out, this should actually work. I'm a little surprised. This is, oh, sorry. Interesting. Let me try this. This is a problem with unknown format directive space. Oops. Dummy. Okay. I messed up something here. There we go. I had a space after each of the tildes, and it doesn't like that. If you have a space after the tilde, it's treating that as a special directive. That's what's causing that error. Okay. But this tilde here is essentially allowing you to create essentially a multi-line string. So one of the nice things about this is now you can split up your strings in multiple lines, still keep it within the context of the number of columns that you want to provide. In my case, although this is still a little bit shorter than I would normally do, I would try to keep it as close to 80 characters per line as much as possible, just to make things a little more cleaner. And what you'd get is the same kind of like help text here that you would, if you like print it out, it'll go ahead and concatenate everything together. And then obviously we can go ahead and replace our help text here, and this is the same thing. You'll end up getting, we call print help, the same idea. Okay. The one thing to note about this is this pattern of breaking up multiple lines, creating very long descriptions of stuff, is so common that apparently this can be refactored into the following. You could just simply use, instead of this, you could simply use adopt define string, and it does essentially the same thing. It'll actually construct the def parameter, the help text, and it's the same idea. All right. This is a little cleaner for some folks, just because obviously less structure in terms of so the parentheses that you have to go through. Also, it's much more cleaner on intent too as well. Format nil, you have to remember that format nil is returning a string rather than a formatted string, rather than formatting to printing to some sort of console or something like that. Once we have our interface, what can we do with it? I mean, we've only provided, oh, I should mention this, shouldn't I? One more thing before I move on to actually building up command line options. sometimes you may want, as you can see here, the usage is again eating into the screen. You may want to restrict the width of what's being printed out. You could certainly do that when you're printing out your stuff too as well, by just specifying a width here. If we actually look at the print help, it takes an interface object and allows you to provide kind of the stream destination that you want to go into. You can actually provide the program name, which I'm guessing is what we can use to replace this with. Adopt. And then the option width is obviously for other things. And now, if you notice, there's also include examples in terms of the documentation. You can use that to essentially provide some of the stuff that we were talking about in terms of actually providing examples for like for very complicated tools that you may end up building. Oh, right, not program name. Sorry. There we go. And you can see here that that's essentially what we wanted. In fact, I'm wondering why program name is not provided in here. That's a little annoying. That should be provided in here so that I don't have to construct it and separately pass it into the object. But okay, that's fine. So now, there's a couple of other things that that we could talk about in terms of help in constructing this interface and making it more mature. But I'm going to wait until we actually construct some options before we start talking about adding some of this additional functionality. All right. For example, adopt also provides, just like UNIXops does, some ability to exit out of your program. It has some ways to actually allow you to provide lists of examples in the example list when you're constructing it. This is all related to creating essentially what you can think of as the textual user interface of your command line tool. All right, and it's all isolated into this make interface function, so you don't have to go and look around your code to figure out where the examples are. Right, but we still not have yet created any sort of options. So I'm just going to go ahead and start talking about options very briefly. We can complete our examples of this time permitting either before we close today or next week. So how do we actually create options? Okay, because this is actually, I mean, this is all good. We're able to construct this very nice, clean, you know, clean command line tool. We're actually building up usage. We're actually providing a default thing here, but it looks like for some reason it did not do what I expected to. Did I accidentally put a space here somewhere? No. Oh, right. 1 second here. We have this ability to, there we go. This is what I was looking for. We're getting these multi-line comments. We have this ability to get our usage in. We have our, we'll soon see examples on creating actual examples of how to run our program, but we haven't actually created any sort of options. So this is kind of like a farce in terms of what is actually available in terms of command line options. So we need to go ahead and build those. So for each one of these, there's several ways of constructing this. Okay. I'm going to show you the first way of actually constructing this, and then we could start talking about uh, next next time on how to use each one of these. But the bottom line is each time you construct a new option, you're going to have to go ahead and provide a couple of things. To create the option, you have the ability to actually go ahead and uh, isolate the option here, sorry, parameter in a function. Let's say that we wanted to create a help option, okay? To construct it, you call the function make option, and this creates an option object. I'm assigning this to this variable. There's a much more shorthand if you want to leverage that I will show later. But this is just so that you can see what the object looks like when we introspect it. Okay, so this make option constructor takes in a name. Okay, the name has to be kind of like a symbol. Okay, it is a symbol. It's quoted. We're using a quoted symbol there. This now takes in now a couple of keywords. Okay, long, obviously, just like unixops stands for the long name that we're providing. All right, and here this is going to be help. Short is going to be obviously the short option version, and normally one has a single character. Then obviously, you want to provide for each option, just like our unixops or even Unix options case, a help to determine what does this actually allow us to do. Okay. So help can be a very short description. Okay. Then there's a couple of other things that are here. Okay. When you're talking about Boolean options, all right, you have this reduction, this ability to actually you want to be able to actually go ahead and reduce the function constantly to some sort of flag of some sort, like either Boolean flag or a simple option for say there are also options where you want to maybe print out the version itself. These guys are very simple options that have simple things. So there is this reduced functionality inside this inside this library, inside adopt, that allows you to what's the best way to say this? That allows you to, when you see the option present in the command line, always reduce it to a particular value, okay? So in the case of Boolean flags, you always want to, if it's present, to always return true, okay? Don't try to compute anything on it, okay? These are just flags that are there for purposes of either printing version information or printing help, or doing something like, say, for example, have a flag to like dump out stuff to the console, right? So these flags are often going to end up using some sort of default value or some sort of value that just needs to be present. So in order for you to do that, you have this ability to use reduce to actually go and return that. And we're going to go ahead and talk a little bit more about this in more detail in a brief minute here. One thing that I want to also point out, though, is constantly, because I'm sure some folks aren't sure what constantly is. So Constantly is just a basic function we haven't actually encountered yet. That's in Common Lisp. That allows you to just always return a value. All right, this particular value. So if you say constantly 5, it's going to be returning a lambda. All right, that every time you fun call it, it's just going to return 5. All right, anytime you fun call it, it's going to be the same thing. All right, that's all what constantly does. So it gives you a nice way of just documenting that this is a constant lambda function that will end up giving you the same value every time. All right. That's what's being used here as our reduction function. There are other things that you may want to think about when you're dealing with reduction, but we can certainly encounter that later on. What other things were here? Result key finally is going to be the identity. There's a couple of other things here that I just need to briefly print out here. And it's easier just to go ahead and do this. Let me go ahead and describe adopt make option. Okay. So if you recall, when we were looking at creating our interface, there were short options and long options hash tables. What we are essentially doing is well, not what we what make option allows you to do is it allows you to provide a shorthand and longhand notation, and for insertion into the appropriate hash table of results. Okay, so when it's done parsing and going through the parsing process and actually returning your dictionary of all this stuff, you can actually specify a custom result key for this. Right now, the key to actually load into the dictionary and look up something is going to be the name of it. So the name that we provide right here, that's going to be essentially your lookup into that hash table to look up to see if there's available, and it's going to use a symbol to actually go ahead and do that lookup for you. Additionally, there is another thing that's available, and that is these two function designators. That's part of the process of actually that is actually part of allowing you to call this. Finally, allows you to essentially convert, after parsing is complete, your value into something else. All right, into something that you ultimately are going to be using in your program. All right, these two values are optional. Reduce itself, though, let me make sure that reduce is kind of like the equivalent of what we saw before, the arg parser in UNIXops. It's used mainly to be called every time the user is specified in it. Like I said, in the case of Boolean flags, it'll essentially call this closure. That's essentially going to take in the information and then return whatever to whatever value you provide into it. So if you pass in a constantly true, it's going to pass in to it's going to always provide true every time the user specifies -h. Okay. We'll go through an example where we're going to actually parse in a parameter. Okay. What is the other one that I want to mention? So let's try. So let's first go through this example here, which we have now. Okay, option help, which we see. This is going to be essentially identity functions. It's going to always return true. It has a result key as being help, which is essentially the symbol for help to actually go look it up, and so forth. Okay. To get this into your UI, all right, you need to essentially pass it in to the make interface constructor. Okay. Well, how do we do that? Well, the way we do that is actually the last argument in this list. That's the contents of the interface, okay? Contents takes in a list that can either be what we saw here as an actual construction help, or you can actually go ahead and make the option if you really wanted to directly in here, okay? I don't know if one prefers one versus the other. But we'll just go ahead and create our port name, port here, to actually be port P, help specify port number A, initial value is going to be what we had, 5,000. We want it to be a parameter. Okay. Don't think I need to specify anything here. It's going to be optional, a string. If given, this will turn this into a parameter. Taking thing, parameter is going to be this. I don't think you need to specify parameter and long at the same time, but we will see what would happen if we have that. Okay. Let's see here. This one short option. What is the other thing that we need? Oh, we need to specify reduce. Okay. And reduction is going to require me to pass in a parameter. So the way that we need to pass in the parameter is okay. I'm just going to quickly show you this particular one, and this one is particularly useful, and then I'll show you one way to clean this up. So lambda here, we can actually provide so this is going to be port. Let me see what this is. So the reason why we need to provide that port as a capitalized is because it's ultimately going to be used in our text here. Do we need? Let me just check to see here what happens if I just pass in a single argument parameter here. There's examples that I'm seeing where they're taking in 2 arguments, but I don't think it's necessary. We'll see if we need to. Really, what we want is a single argument that'll take us parse integer and returns the argument that's passed in. So this now, if we do adopt print help, UI, you'll start seeing okay, so it looks like we do not need okay. So it looks like this is all working. Let me go ahead and provide a default 1000 here. And we can get rid of that in our long description. Which makes this guy pretty much simple now. Okay, so we now have this done and this done. Okay, and this now cleans up our UI accordingly. Oh, let me go ahead and do is that width 80, so that people can. This is actually changing this, but it doesn't actually change. Oh, sorry. Program name. There we go. So we now have kind of defaults. We've cleaned up the unit. We have our options. We're getting close to actually being able to take this for a test drive and check what where we're ultimately going to be used. And I'm not covering every single kind of things here. Because in Adopt there's things called option formats. There are things called there are ways to actually grab the options and spit them out, and there is different ways of actually computing values. I have to come up with an example, and I'm not entirely sure right now off the top of my head to do in terms of this particular program that we're building today, but you could probably see that there's ways to also handle, collecting every parameter that's being passed in. But the structure does not change in terms of how you might end up utilizing this this program. Okay, so we now have our UI. Let's go ahead and talk about what we were talking about in terms of adding examples, and let's build up our exiting, and then we could start talking about actually command line parsing here. All right. One thing to note is we provided our contents, each one of these things that we're adding is just yet another option that's inside make interface, okay? To create examples, for example, here, what you'd want to do is essentially call out examples. And what this will do is it'll allow you to go ahead and provide a list of examples. Literally, the way you would normally provide it is use an associative list, where you create a set of dotted pairs here. We can do list here. I prefer doing this, but you can also do this, which is let's say start echo client on a particular port. Sorry. client. Well, let's say start echo client. On host name, port. Okay. And you could provide a dot here and then provide the example. Let's say, so the echo client adopt -h host name -p port. Start echo client on host name defaulting to port. Using default port. And again, this is just echo client adopt host name, and then obviously these are just using the shorthand notation. I'm just this help examples. I'm just doing this for illustrative purposes. You could use either or for your examples. Echo client adopt -h. Okay, so now we have our UI. When we build it, we can see it generates all these different examples for us very nicely. One thing that we have not yet tried that I think is particularly useful is checking out the man page thing that they talked about. So let's go ahead and do that. Make interface. What is let me see, manual. Go client adopt. To use in place of help when rendering a man page. Let's see what this does here, because I'm not entirely sure what it's going to do. It looks like it doesn't actually change our structure at all, the way I expected it to. But I doubt it actually generated any sort of page for us, but we'll see. Let me go ahead and check. Did any sort of like... Oh, right. Sorry. This won't show up. These are my list of open buffers. Okay, so adopt doesn't actually do any sort of like generation for additional help pages. It will actually just go ahead and, if you wanted to construct a separate man page for your command line tools and you're using it, it will allow you to essentially change the string that it generates to start off the man page. That's essentially what that manual keyword is for. All right. To use in place of help. So when you're doing like when you're actually creating your man page and stuff, and if you wanted to actually go and construct a different page, command line string that's going to show at the title of your page, that's when you start using :manual. Okay, so we created our examples, we created our things. Let's talk quickly about exiting and printing out some stuff. So before, when we were talking about unixops and we were talking about other things, we actually had to go ahead and construct kind of a help and then handle specifically the case where things are unspecified. So if you recall, and let me just quickly pull up here our UNIX examples. And the reason why I'm covering UNIXops more than UNIX options for comparison is because UNIXops also tries to be like opt-parse and arg-parse, so it's much similar in terms of its nature. In this case, we know that when anytime any of the required options gets thrown, we actually end up describing explicitly what R is, and then we go ahead and exit here. With adopt, what you would have to do is you can actually go ahead and, I'm a little afraid to do this, but it's going to have because it's going to kill my REPL, but I'll do it anyway. There's a function called help and exit, and there's also a function called and it can take several other things, and then there's also print error and exit too as well, which is an error code. And you can use either or. This one takes in the interface object, okay, UI. Again, you need to pass in the program name that you want to grab. Notice, for folks who are paying attention to the mini buffer here, in program name, and I didn't illustrate this before, but I should have, it by default actually takes in the car of the adopt argv. Adopt argv is essentially the same as unixops/image raw command line arguments, where it's taking the whole list including the program name. So that car is actually just grabbing the command, the program that you ultimately passed in. So if you built this differently than what is actually provided, it's going to grab that straight from the command line rather than you providing it for us. Here, we're going to just go ahead and directly provide it, since we don't have, we're mimicking this on the command line. I mean, sorry, on the REPL. So we do that, and then obviously we want to change our width to be, 80 characters. Let's do 80. That's actually the default, so that should be fine, actually. Now, when we do this, by the way, it's going to actually allow us to provide a different exit code, okay? So if we do this right now, for example, it's going to go ahead and kill the Lisp connection because it didn't actually, and it won't actually print out anything. Well, it did print it out. It printed it out and then it aborted, all right? And then it killed our Lisp connection because, again, the exit code is going to be slightly different. Now, let me go ahead and restart this here because I wanted to show you something else related to this. Give me a second here. Where are you? That. A new one. And let's go ahead and do this again. Okay. Oh, shoot. There we go. All right. One thing to note about print help and exit is you can actually specify which stream you want to actually attach to. Obviously, I don't think there's a... Right. Obviously, by default, it's going to print out to standard output, but you can also specify it to go into essentially the global error output as well. So you could specify a different stream here. And you can also specify an exit code different than what was provided. So folks who really know Unix, remember, on success, you're returning 0 because nothing's happening. Otherwise, you're going to give it some sort of exit code that's going to be registered with Unix so that you can actually go check to see that the exit code is actually correctly passed in. and then you can use this to actually go and throw an error to as well. This will again do what we did before, which is going to kill the program. If you are actually one thing to note is if you are going to leverage print error and exit, or print help and exit, to appropriately put it in the right place. So, like for example, in our case here, we'd want to put it inside our beginning example here, and to show off what it is that we're illustrating here. And let's do that final thing here. Sorry, it's I'm going a little over here, but I'm just going to go ahead and knock this out because I think this is particularly important, and it's kind of interesting as we're going through it. So let's go ahead and do that. Let's go ahead and compile, adopt, print help. Oh, sorry, I forgot to do this. Alright, so here, for now, just to show you guys this, let's go ahead and do print help and exit. Why? Notice I'm not actually providing the program name. I'm just going to provide the stream that we're going to be writing our error code to, because we're going to see how it interacts with the actual shell. We're going to also provide an exit code here because if we're ever going to actually end up leveraging this for other cases, it's useful. Notice there's also one more function here before I run through this one example with help and exit, which is called error and exit, and we're going to see this in a minute. This one is particularly useful for handling specific errors, and it allows you to also run different command line options. And again, this is all related to parsing our options, and hopefully time permitting I can go through that too as well very quickly. But I'm just going to go ahead and show this one first. Alright, so we are now good. Let's go ahead and, that's right, I have to keep this guy available here. So I stop getting that. Let's work Ross build. Oops. Sorry, Ross build echo client. Okay. Let me also. Okay, so let me do this. I'm gonna show you guys this since we compiled compiled it now. Let's go ahead and just call it normally. We're not going to provide any command line options at this point because we're not actually parsing anything yet. This essentially is what is spit out. To show you, what was it? Here's a command to actually run. So to check to see that our exit code is correctly executed, if we just do in bash, if you run this command, we'll give you the exit code. And you can see that the command does, we should actually echo it. You can see that the exit code is appropriately set to 0. Set to 1. You can set this to any exit code that you want. Usually 0.1 is being used. There are other exit codes that you want to use for different use cases. Obviously, I defer to any UNIX documentation as to figure out what the appropriate exit code is for your particular use case. But once you do have it, you can just go ahead and check to see that the exit code is actually being passed in. So if we passed in, say, for example, -1, okay, instead of 1, okay, and we run, and this can be anything appropriate, success or failure. There's a couple things that are already normally I think there's you can go look up in unistd.h for some constants already available for you for Unix programs for consistency. So okay, so if we do this, you can see that it's going to be an overload because it's unsigned. It's an unsigned integer that's being returned. So by passing in -1, you're actually passing in all ones here, which is 255. So let's not try that right now for the time being. So we talked to some of the examples here. I'm just going to quickly show basically one last thing, and that is parsing the options, and then we'll next week be a little bit more robust and handle the cases of actually using adopt for error handling and dealing with adopt error handling as well. To parse your options, essentially you have the adopt parse options here. And adopt parse options does actually return kind of like a hash table of things here. So I'm going to show you very briefly this guy here on the command line. We'll incorporate this next time. But parse options basically does this. So if you take your UI and let's say that you pass in a list, okay, right now it takes in the rest of the arguments of argb, but we're going to pass in an explicit list here. And let's say that we pass in H, and we pass in localhost, and we pass in P, and we pass in 5000, right? So, we get our first error. No such option -H. Did I forget to provide? Oh, sorry. I forgot that we did not provide, we have not implemented the -H option yet. I will go ahead and implement that in a minute. But when we go ahead and pass in this parse options, what is invalid number of arguments? Okay, so this is related to that parameter thing that I was dealing with earlier. Okay. For some reason, what's passed in is the previous value and the new value. we're ignoring the previous value and always going to deal with the new value. So this is done. Let's go ahead and parse this guy again. Okay, so the reason why there's previous and new values is the fact that in some cases you may want to compare the two when you're actually creating your options. I'm not entirely sure in what cases that would be necessary, but another case that you could do is you can also use instead of doing this, you can also use something called adopt last. But adopt last is going to give you a string. It's not going to actually give you an integer. So if you do this instead, we'll end up getting this. And if we actually go look at our port, you'll see that the port is set to 5000 here. Whereas in this case here, it's actually correctly set to what we expect, which is an integer value. So there's some advantages and disadvantages of doing that. I'm not entirely sure for some of the validation stuff in what case you'd want to do this, but if you're doing more like actual validation, you could do the approach that I was taking, which is obviously not use adopt last. Adopt last is kind of probably be useful for, say, if we wrote, and I could probably just whip this up very quickly, the host name piece of our puzzle. Adopt make option host name. Well, let's call it host so that's easier for us to actually type this in when we're writing the code. Host name here. Well, let's say host here for h help specify host name, host address. Parameter host name. Let's call this host address here. Okay. And our reduction is going to be just dot last. And this is kind of nice for our case just because if you look at this, immediately it's going to become apparent I didn't have to do something that I had to do with UNIXops. UNIXops, when you parse in the command line options, it actually essentially did, I had to use, had the arg parser for strings. One of the read functions, okay, sorry. Specifically, if you go and look at it, I was using read from let's go to this again. I essentially grabbed the string directly because in the arg parser, it actually uppercased the string that I was passing in. It wasn't actually taking it literally, and it actually created it into a symbol, which caused some issues. In this case here, I didn't have to do that. Adopt last actually does the right thing, in which it actually goes ahead and gives me literally what is being passed in from the command line, which is very useful. Right? Let's show you one other thing here, and that is, let's say if we used --host instead, okay, you're going to get the same kind of hash table that you would before. Here, you can see host is still being converted into the appropriate host name and so forth. And the reason is that when it essentially does a flatten. It's flat. It takes both the long options and short options and gives you a single dictionary, a single hash table that you could then use for your parsing needs, which is pretty useful. So you don't have to actually go through all the short options and long options. You just have a single hash table that's returned by the parse options function that you could then use to actually grab what you need from the dictionary for starting up your program. What else did I want to cover today? So we're way over time today. I apologize for it. Next week, we're going to go ahead and continue our discussion of adopt. Specifically, we're going to end up talking about error handling, how to deal with required options, some of the conditions that are available in it, and I just found out from the manual, how do we generate the man pages that we want for our tool. It looks like it does turn out it is. It's just that the manual doesn't necessarily get generated until you explicitly call it out. There's a function actually. I'm going to show you just a taste of what we're going to be covering, but basically you can use print manual here to dump your man page, and you can see this is the man page. For folks who haven't actually ever seen a man page markup before, this is man page markup. So it will actually generate man page markup for you based on the name that you provide to the actual program, and then it'll go ahead and generate all the examples for you. So, which is very, very useful. A lot of folks expect a lot of command line tools to be leveraging the man system to actually go and look up examples that they can then copy paste into the command line. So, but we'll cover that and other things related to finishing off our Echo client using the adopt library next week. So I appreciate you guys staying on over time. Thanks for joining me today. Quick announcement, just a reminder for folks that our Haskell study group is still on schedule for tomorrow from 1:30 to 3 p.m. Eastern Time. We'll be continuing and finalizing our journey through type classes. I hope you guys who are in our Lisp group also join us for our Haskell study group as well. I'll see you guys next week for another episode of the Common Lisp Study Group. Thanks for joining. Bye.